So it says that let f be a function with f of 1 equal to -4 and that the slope is given by that following condition. So by telling me that the slope is given by this, that is the same as telling me f prime of x, which is really dy dx, is equal to 3x squared plus 1 over 2y. So immediately I'm seeing that as a differential equation, and I'm going in my head, okay, I need to cross multiply, so y's are with y's, x's are with x's. If I'm looking to find f of x, I need to integrate f prime of x. So we are going to integrate both sides. I don't want to put my integration following this because that's not the same. They're not equivalent. These all represent the derivative in different orders. However, this represents something totally different. So integrating both sides, I get 2y squared over 2 equal to 3x cubed plus 1x plus c. So now I have like two choices. I can solve for y, or at this point, which is my preference, I can solve for c. So I'm going to use the initial condition to find my c value. So the initial conditions are f of 1 equals -4. Because at this point, this equation represents f of x because you integrated the derivative. So I get that the c value is 14. Taking into account that this point right here is 1, -4, that's going to interpret what part of the y value I use now that I plug in my c. Sorry. All my c's are now a 14. And again, if I plug in a +1, I need my y to be -4. So if I'm taking the square root of both sides, in the case of this problem, my f of x needs to be the negative square root of x cubed plus x plus 14. I could use this same problem to find the equation of the tangent line. So if I took that same problem and I manipulated it and it said find the equation of the tangent line, then my equation of my tangent line would be dy dx evaluated at 1, -4 to the original slope So I would get that my slope is -1/2. The equation of the tangent line is going to be y minus that -4 equal to -1/2 x minus 1. Okay, function f is differentiable for all real numbers. So again, that's kind of important. If it's differentiable, differentiability implies, so it's also continuous. The point 34 is on the graph of the original function. And the slope at each point is given by dy dx. Find the original function by using dy dx with that given initial condition. So once again, you want to get y's with y's, dx's with dx's. So I'm going to divide both sides by y squared, and I'm going to multiply both sides by dx. Upon doing that, I'm going to integrate. So 1 over y squared is really like y to the -2. So when you integrate, you're going backwards. So that becomes y to the -1 over -1. So I get -1 over y equals 6x minus x squared plus c. At this point, I can plug in to solve for c. And I get c is equal to -13. So ideally, this situation is kind of gross because y is in the denominator. So what we're going to say is, okay, this is like negative 1 over y equals 6x minus x squared minus 13. But what we're going to do is multiply both sides by y. So these y's cancel. That y's now over there. If I want this y to be isolated, I'm going to divide by my 6x minus x squared minus 13. So I ultimately end up with y equals negative 1 over that.